Okay. So for number 8, for all problems really, you should always take out the GCF first. So we have 5x squared minus 40x plus 75. You guys told me the GCF was 5. You can find that in Desmos. We're going to divide everything by 5. The 5 is the GCF that goes outside the parentheses, and then we do our division. This is going to be x squared minus 8x plus 15. Let me just check the chat. Is that what I told you? Or no? Oh, okay, good. All right, so let's go into the show your work. And when we go into the show your work, you're only taking what's inside the parentheses into it. So the 5 is the GCF, that goes in the first blank. Now we're just going to try to factor this further. So that way our final answer is going to look something like this. It's going to be 5 times and then 2 sets of parentheses. But we already have the 5. So now we just need to go into the show your work box and factor what we have left. So let's open this up. Okay, what did we have left? We had x squared minus 8x plus 15. So a is 1, b is negative 8, and c is 15. It's asking for a times c here. So 1 times 15 is 15, and b is negative 8. Those numbers also go in the chart. We need 2 numbers that multiply to 15 and add to negative 8. You might have started with 1 and 15, 3 and 5, but none of those have a sum of negative 8. I did get positive 8, but I need negative 8. So let's think about that again. Is there something I can do with my table so that I get a product of 15, but a sum of negative 8? What do you have to do to the numbers? Make them both negative. Very good. So let's change them both to negative. Now, why did I do that? Because negative 1 times negative 15 is 15, and negative 3 times negative 5 is also 15. If you add those together, you're going to get negative 16 and negative 8, and now we found our winner. That's our winner. Okay, let's see. So now I think there might be some students that are still struggling with how to write the box. So let's talk about that. The first term comes from the first term of your polynomial. So our first term is 1x squared. The last term is just the constant. So the last box is the constant, which in this case is 15. And then the diagonal, which is here, comes from the 2 numbers you found. So we're going to say negative 3x and negative 5x. It doesn't matter the order. Okay, so far so good. Let me just see if there's any questions in the chat. Okay. All right, now we need to factor. There's a little hint for you above each column. And there's also a little hint for you next to each row. So let's read those. Starting here, I need to find the GCF of column 1. 1 and negative 5, they don't really have a common number, other than 1. But of the variables, we have an x squared and an x. I can take an x out. So I'm going to put an x there. Now I'm going to go to the second column. Negative 3x and 15, you can take out a GCF of, technically you might be thinking 3, but if the first term is negative, go ahead and take out a negative 3. And now we go the other way. Now we're going to go to the rows. So I'm circling the rows. The GCF between 1x squared and negative 3x is just x, And the GCF between negative 5x and 15 is negative 5. If you're not sure that you're right, you need to pause and like actually just check it. Check it by multiplication. X times x is x squared, so that first box is right. X times negative 3 is negative 3x. Had you put just a 3, you would have realized you're wrong. So you can always check your work to make sure you're right. Negative 5 times x is negative 5x, and negative 5 times negative 3 is 15. So I feel like all of this is correct because I checked it. My final answer is what you wrote on the sides of the box. So on the sides of the box, I wrote x minus 5. That comes from the left side of the box, and then the top. But the order doesn't matter. So you could put x minus 3, x minus 5. So our complete answer is 5, which was the GCF, and then x minus 5, x minus 3. Always take the GCF out first. So if you see a GCF, pull it out first and then factor what's left. Okay, let me look at the chat. Okay. All right, I don't see any questions in the chat. I'll leave this on the screen for a couple of minutes just in case anybody has more questions. What number was that? That was number 8. Yeah. Okay, so some hints for number 9. Be careful. There's definitely a GCF here that you want to take out first. So let me just write a note. Always factor out the GCF first before trying any other methods, like before you ever go to the box or anything like that, or difference of squares. Always do GCF first. Okay, is there a GCF between these? For sure. I mean, they both have an x, so I know there's at least an x GCF. There's also a number GCF, though, so what's the number GCF? Three. Yeah, so I would start by maybe writing the problem down. I would write GCF is 3x, and then go ahead and divide by it. The GCF always comes to the outside of the parentheses. Remember, when we first talked about GCF, we said that meant undistributing. So that's undistributing property. If you do that, you're going to be left with x squared minus 4. Let's see. So now we know we've got a 3x that goes here. You probably don't need the box for this one. Like, many of you guys are just going to do this problem using the trick we learned yesterday. Those are perfect squares. So I would just use that like square root method if I were you. But if you are going to do the box method, don't forget b is 0. So if you are going to do the box method with this, don't forget that the b value is 0. All right, awesome. So I will let you finish that one. And just let me know if you have any questions on any of the other problems. All right, so let's take a look inside the box. This is for number 9 still. We took a GCF of 3x out. And when we did that, we were left with x squared minus 4. So you already know that there's a 3x on the outside. So don't do anything with that. You took the GCF out. You're actually just factoring what's left. And you have two methods for doing that. Like, method 1 would be to use the unboxing method, but just be careful because b is 0 in that case, right? A is 1 because there's an imaginary 1 here, b is 0 because I don't see any x terms, and c is negative 4. Or you could skip this method completely and just do this method instead. Bring your 3x down and just break this down using square roots, right? Square root, that goes there, that goes there, there. I'm not going to do the whole problem, but if you need help with difference of squares, there was a video about difference of squares inside the formative somewhere. I can't remember what number, maybe number 6? It was attached to one of the numbers. So if you need help with the difference of squares, go back and watch that video.